First, does anyone need another path of questions? Do we have, we'll go section by section. So, questions on the first section? Regina? 2? Okay. So remember that this section is no calculator. But if you want to use rulers, you're more than welcome to do that. If you want to graph them in 2 different colors, you're also welcome to do that. So you need to graph both of these lines. For the first one, where would we start? -1. And our slope is 1/2, so up 1, right 2 as many times as possible. Down 1, left 2 as many times as possible. However big your graph is, fill up the entire graph. Connect all your points and draw a line. And then the same thing with the second one, except this one starts at +2. Up 1, right 2. Down 1, left 2. And then you're looking for the solution. What type of solution would these have for you? No solution. They don't cross. Other questions on this first section? Regina. So 4, we have to solve both of them, get them both back into y equals before we do anything else. How would we do that? Regina. You're going to do that for both of them at the same time. You have 3y equals -8x plus 12, and 3y equals -8x minus 9. And then our next step, divide everything by 3. So the first one would be y equals, this is going to stay a fraction, -8/3x plus 4. The second one is y equals -8/3x minus 3. Before we graph them, what do we notice about the 2 equations? They have the same slope. What is that going to tell us about our solution? Notice. And that means what for our solution? Which is what type of solution? There we go. Okay, so the first one, we would start at +4, go down 8, and to the right 3. And the other one, we would start at -3 and go up 8. And left 3. And these do not cross, so it would again be no solution. Remember that to check if points are true or if points are the solution, put it into both and see does it work or does it not. If it doesn't work for both or one of them, it's not your solution. If it does work, then it is. Next objective. Any questions in the substitution piece? Regina. 10. So usually your equations will have one of them will have x or y almost solved by itself. This one does not, but that's okay. So then, because it doesn't, we have a choice of what we want to solve. I would say probably solve for one of the y's because you'll have nicer fractions than if you solve for one of the x's. Which one you choose is up to you, but I'm going to choose this one. I'm going to get this y by itself. Subtract 3x on both sides. And divide everything by 5. These should give you nice decimals, so if you want to change those to decimals instead of fractions, you could do that. So 0.6 and 2.6. What would we do now that we've solved that piece? What's the next step in substitution? Yeah. Take this piece, put it in the other y, rewrite it. And then solve. So you have negative 6x plus 16. Plus 6x plus 1/6. But when we combine and let terms, these go away. What type of solution is that? Because 26 equals 26, that's true. If they canceled and you got 26 equals something else, that would be no solution. If they don't cancel and you get an answer, then it's one solution and you find both. Any others in the substitution piece? If not, any questions in the elimination section? So remember your rules with elimination. Your coefficients have to be the same. What you choose to eliminate is up to you. They're both the same. So whether you choose x or y doesn't matter. What do we want to eliminate? X or y? Okay. If we're getting rid of y, these need to be the same. So we need to multiply them to be the same thing. We could multiply the top by 10 and the bottom by 7. I feel like that's the only thing that would work, but I could be missing numbers. Remember that when you're multiplying it to everything in there. So the first one would become negative 70x minus 70y equals 0. The second one would be negative 70x minus 70y equals 0. Then to eliminate our y's, would we add these together or subtract them? Subtract, because whatever the signs are, if they're both the same, you're always subtracting. However, these are the same, so this is going to become 0. This is going to become 0. You have zeros everywhere. So this is an elimination. years. Other questions with the elimination? Yeah. Alright, for 21, do we have common coefficients or similar coefficients? Yes. Which ones are common or similar to y's? So we don't need to add, multiply anything. Would we add these together or subtract them? So then add them together. 1x plus a negative 5x will give us a negative 4x. The y's would cancel. 11 plus a negative 23 would be what? Someone said it, but I didn't hear it. And then divide, solve for x. And then once you have your x, go back and solve for y. Does not matter where you put that in. So let's say I put that into the first one. 3 minus 2y equals 11. And now I'm solving for y. So y equals negative 4, and you would write your final answer in parentheses. If you wanted to double check that this works, you could put 3 and negative 4 into both x and y for both equations. Solve them, see if they work. Other elimination questions? And then word problem questions. Remember that with the word problems, the most you need to remember is how to set it up. The solving, you choose, well, it won't be by graphing, but it'll either say solve by elimination or substitution, or you'll have a choice. So important things in here. Madison bought 2 chicken sandwiches, 3 bowls of vegetable soup for $16.50, not including tax. Cliff bought 1 chicken sandwich and 3 bowls of vegetable soup for $9.50, not including tax. What is the cost of a bowl of soup? So we need 2 variables. What do we want to call them? Two letters we want to use. Okay. So let's say X is related to the chicken sandwiches, Y is related to the vegetable soup. What don't we know about them? How much they cost. So cost of the chicken sandwich. Cost of a bowl of soup. Remember that when you define your variables, you need to be specific. Cost of whatever, amount of whatever. Okay. We have our variables, we have our numbers, we have 6 numbers, so they're all going to get used. Anyone want to take a guess as to how we would write our equations? Okay, so we have our equations now. Now we need to pick a method and solve. Which method would work best for for what we have. Because we already have common coefficients. So would we add these together or subtract them? Now, as we're subtracting, we're going to end up solving for x and have to go back and solve for y, but that's okay. So this would give us x, these would cancel, this would be, what's 1650 minus 950? So we know the cost of x, now we have to go back and find the cost of y. I'm going to put it in the second one. So we would subtract 7 and divide. I'm going to divide that from each other. So in cost, we would put that as 83 cents. Or so that would be the answer we're looking for. It was, but we're looking for the cost, so we can't write all the decimals. So we would just stop it. But yes, you would also round it. So this one is a word problem, but not at the same time because it's really just their numbers. Anyway, so 5 times Jasmine's number minus 3 times Josh's number is equal to negative 16. And then it's also true that 4 times Jasmine's number plus 5 times Josh's number is equal to negative 35. So our two variables would be something related to Jasmine and Josh's numbers. I'm going to call that A and J. For Jasmine's number and Josh's number. And then it basically tells you how we're supposed to set this up. So 5 times Jasmine's number minus 3 times Josh's number is equal to negative 16. And then 4 times Jasmine's number plus 5 times Josh's number is equal to negative 35. You could do substitution here, but we're just going to do elimination again because that would be easiest. We have to find the value of both, so it doesn't matter which one we eliminate first. Which one do we want to eliminate first, A or J? You guys choose. Okay. So if we're eliminating J, what could we change both of these two so that they're the same? 15. So multiply the first by 5 and the second by 3. We have 25A minus 15J equals whatever that number is. What's 16 times 5? Negative 16 times 5. And then 12A plus 15J equals 35 times 5.
Times 3, sorry.
And then would we add or subtract our J's together? Different. 25 plus 12 would give us 37. Cancel. This would become negative 185. And then divide.
What would A be?
Is that what we all got?
Yes, no, yes, no.
So then we need to find the office number. Put it back into any of the 4 equations, doesn't matter which one. Let's say the first one. We have negative 25 minus 3j equals negative 16. Add 25 to both sides.
What is that? Negative 16 plus 25?
And then divide.
So the label on this, you wouldn't really need one because that is the number that we're looking for. We're not going to do 26, but I will say as you're reading it, count each X as a 1. So that might help you when you go to set that up if you're practicing that. Do we have any other general questions before you guys take your quiz? I did pass out your Unit 8 binder checks, so go ahead and get those papers together if you haven't already. I'm going to designate this front table to be papers and the back shelf, and then you guys can move anywhere else. Jaden, up here. Put it up here. Jaden. Put it there. If you guys have open seats next to you, you can put it there. But this table or the back shelf. And then once you're ready, you can put your calculator off to the side or away, because you're going to start with the no calculator, the systems by graphing first.